Alright guys, today we're going to talk about how to do the procedures and methods portion of experiments. So I'm going to go ahead and move me over to this side because I think we're going to be safe there. Alright, so first we need to make sure that we take care of our variables, and these are the things we've been practicing in class. So you need to make sure that you record the independent variable and include the different levels of the independent variable. That means the different ways you're changing it. So if you're testing the effect of the amount of water on plant growth, then your different levels of the independent variable, because independent is the cause and the cause is the amount of water, your different levels would be the different amounts of water you're giving to the different plants. So for example, my different levels may be 10 milliliters of water, 20 milliliters of water, 30 milliliters of water, 40 milliliters of water, and only natural ways of getting water. Those might be all my independent, or the levels of my independent variables. So the independent variable is the amount of water. The different levels is the specific amounts that you're giving. The dependent variable and how you're measuring it. So here I'm measuring plant growth in that example, and so plant growth would be measured, let's say, in centimeters with a ruler, a metric ruler. Control, whatever you're comparing to, are not changing at all. So in that example, that would be the plant that receives only natural ways of getting water. And then constants, the main things that you're keeping the same in the experiment. So for that example, you would want to keep the amount of sunlight the same, the amount of, or the type of soil the same, stuff like that. So you need to list those things and that information about each of those things as a part of your methods. Then you're going to move on to, let's try down here, okay. Figuring out how many trials you want to do. Now, a trial is a repetition of the same experiment or the same conditions for each level of the independent variables. So why do you want to repeat it? Well, multiple trials, when you do more than one trial of each condition, it allows you to see whether the results of each test show consistency. And consistency is how we reinforce our conclusions. If we don't use multiple trials, we're not sure how reliable our conclusions are. Maybe when we did the experiment, the results we got were a fluke. They aren't actually how it normally happens. And if we would have done multiple trials, we would have seen that the first one we did, which was a fluke and different, all of a sudden, in the next two trials, it didn't work the same way. So something was different, something went wrong in that first one, and if we didn't do the other trials, we wouldn't have known what. It's recommended that we use at least 3 trials for each level of independent variable. So in the example I was using before, that means that I would need 3 plants that were getting watered with 10 milliliters of water. I would need 3 different plants that were getting watered with 20 milliliters of water. I need 3 different plants that were getting watered with 30 milliliters of water. I'd need 3 different plants that were receiving only natural ways of getting water. So those are the 3 trials, as you have 3 examples. Okay, materials. As a part of your procedure and methods, you need to list your materials, and this is just a bulleted point, and this is going to include how much you want of each item or how much you're going to use or need of each item, and it should always include safety devices. So if you know you're going to need gloves, you need to make sure you write down how many pairs of gloves. If you know you're going to need an apron, you need to write down your apron, stuff like that. And then the procedure. So here's where you actually are writing like almost a recipe for your experiment, because you're being super detailed. You're telling us how much to use and when. And it also would allow, so you're writing it so detailed that it should allow somebody else to take your procedure and do it the exact same way you did it so that they could repeat your experiment. Remember that the more times an experiment is repeated, if the same conclusion is reached, the stronger the conclusion. Your procedure should also be written using good technical writing skills. I know you guys know how to write, so this should help you practice writing or continue to write well. All right, so I put together a checklist for what makes a good procedure. You're going to refer to the checklist, and I'm going to show you it on the following slide, to make sure that you have everything. And you should answer yes to every question when you're creating your procedure. So, it might be kind of hard to read all this with me in the way. All right, have the experimental structure. So you need to make sure you've listed your independent variable and all the levels of the independent variable. You need to make sure you've listed your dependent variable and how you're measuring it. So not just plant growth, but you're just testing the height of the plant or change in height of the plant. And then have you listed your control and your constants that you will use. Materials, you need to make sure you've listed all the materials that you will use, as well as safety items. You need to make sure you've included the quantity of each item you will need. And then the procedure. Have you included a step-by-step list of what you're doing in the procedure? Have you described how to change the independent variable and how you're going to measure that change? In other words, if you're doing the amount of water on plants, I'm going to use a graduated cylinder to measure 20 milliliters of water out. That's what I mean by that. And then have you explained how to measure the resulting change in the dependent variable? So my example, I'm going to use a metric ruler to measure the height change in centimeters. Have you explained, how the contents will be maintained at a constant value? So in other words, how are we keeping things the same? So in that instance, am I keeping all of my plants in a room to make sure they only get the same amount of sunlight? How am I keeping those other constants the same? Have I included how many trials I'm going to do? So in my procedure, have I included that I'm using 3 plants for each condition in the example? And then the ultimate test, if you were to give your procedure to somebody else, could they do the experiment exactly as you were doing it without you supporting them at all? In other words, could they just read your procedure and understand it? All right, so here's my I do. So my observation, I'm going to go through all the steps of the scientific method we've talked about so far. My observation is I noticed that my friend's flowers are growing way taller than my flowers. She mentions that she's using a fertilizer on her plants. I wonder if different types of fertilizer would affect the plant height. So my scientific question would be, how does the type of fertilizer affect the height a plant grows? Then I'm going to do some research. So after my research, I'm going to write myself a little paragraph. And for this, I say, after researching, I find out that different fertilizers are made with different types of elements. Certain elements are used to make plants grow taller, such as phosphorus and nitrogen. Some other fertilizers are made to kill weeds, and they have specific types of weed poisons in them. So then I'm going to form a hypothesis based on my research. So I think if I use Miracle-Gro fertilizer on my flowers, then it will make my plants grow taller because Miracle-Gro has more nitrogen and phosphorus than the other plants, which the plants need to grow. Remember that your hypothesis should show a cause and effect, should answer the scientific question, so I have to make sure that answers my scientific question, and then it should be written if, then, because. My procedure. So I'll start with the experimental structure. So my independent variable is the type of fertilizer, and so my levels of the independent variable will be the different types of fertilizer I'm going to use. So I'm going to use Miracle-Gro, I'm going to use Scott's fertilizer, I'm going to use Vigoro, and I'm going to use one with no fertilizer added. My dependent variable is going to be the height of the plants, and I'm going to measure with a ruler in centimeters on a daily basis. My control is the plants planted with no fertilizer, right? Because that's how it would normally be in nature. That's what I'm comparing to. And my constants would be things like the type of plant I'm using, the amount of time they're allowed to grow, the amount of water they're given, the amount of sunlight they're getting, and the temperature of the air. So in my materials now, because I'm still in the procedure methods, which is materials, I'm going to take 12 poppy plants, 12 pots. I'm going to need a gallon of water for watering, 200 grams of each of these different fertilizers. I'm going to need 1 greenhouse. I'm going to need 1 set of garden gloves, 1 shovel, 1 bag of regular soil, and 1 tablespoon. So now I have my, I don't know if you're going to be able to see it all. Yep, okay. So my whole procedure, so put on your gloves is my very first thing. That is something I included in the materials, and it's a safety thing that needed to be included. So then I'm going to put regular soil in a pot so that it's about half full. Put the poppy plant into the pot. Measure the height of the plants and record the initial height in the data table. I tell you when to record heights and when to not. Fill in around the poppy plant with soil. Repeat with each of the 12 plants until they are planted. Take your tablespoon and scoop out 200 milligrams of regular soil from 3 of the plants and replace it with 200 milligrams of Miracle-Gro. With 3 other plants, repeat the same process with Scott's. Then with 3 other plants, repeat the same process with Vigoro. With the last 3 plants, do not take any soil out. Water the plants with 20 milliliters of water at 6 a.m. and at 6 p.m. Measure and record the height of the plants in your data table each day at 4 p.m. Then calculate the change and record in your data table. Repeat steps 11 through 13 for 15 days. That means I'm repeating the watering, the time at which I'm recording, and the calculations every day for 15 days. So that would be how to write a good procedure. So we are going to continue to practice this. You will get opportunities to. So I hope you understand and that you've taken some good notes. And yeah, thank you.